Alright, so now I'll be covering lead code problem number 690, which is employee importance. So you have a data structure that is given to us for employee information, including the employee's unique ID, importance value, and the direct subordinates IDs. Right. So you are given an array of employees where employees of I.id, that is for the ith employee, ID is given. The importance is also given, and the subordinates is a list of the IDs of the direct subordinates of the ith employee. So subordinates are basically the employees, the people working under that particular employee, right? So that employees juniors. Now, given an integer ID that represents employee's ID, return the total importance value of this employee and all the direct and indirect subordinates. So what we need to do is we need to return the total importance of that particular employee, as well as all the direct and indirect subordinates. That is, let us say if we have a CEO at the top, right? If we have a CEO at the top, and there are some general managers as well, like GM1, let's suppose GM2, GM3. So, and there are junior level managers as well, right? Let us say GM1, GM2. Let us say these are the things. These are the categories here. So we need to return the importance of the CEO. So that would mean that we have to return the total importance of this CEO along with all those employees working under him. So that includes all the values under this subtree. That is the importance of GM1, GM2, GM3 added along with these as well, the junior managers as well, right? So that is what we need to do. So this basically is a similar question to the subtree sum that we just saw in the previous video. So here also we have to calculate the subtree sum for each of the employees. So the sum is basically based on the importance value, right? So for this example, let us see, we have importance is equal to 5 for the root node, that is ID equal to 1. And how are we going to check for this? So basically this is the vector given to us of employees. So an employee basically it stores firstly the employee ID. So ID is equal to 1 here, and the importance value, that is equal to 5. So ID equal to 1, importance equal to 5, and its subordinates, that is ID equal to 2 and 3. So ID equal to 2 and 3, right? So we make a tree like that, and then for ID equal to 2, we can check that we have importance equal to 3. That is the next value in the list, and here as you can see that this is null, this is empty, right? So it does not have any child. That means it does not have the employee with ID 2 does not have any junior employees. And similarly for ID equal to 3, we have importance equal to 3 and no other junior employees, right? So ID is also given to us as 1. So for ID equal to 1, we need to calculate the total importance. So that would mean that calculating the importance of the this employee along with the employees under him, that is importance 5 plus 3 plus 3. So that would mean 5 plus 6, that is 11. So that is exactly what is done here. That is the answer. Now let us say for this example, we have importance equal to 2 and importance equal to minus 3. For ID for employee with ID 5, our answer would be importance equal to minus 3, since it does not have any other further employees working under him, right? So the importance would be minus 3 itself. So no direct subordinates are there, so that is 1 minus 3. So that is basically the problem given to us. And now let us go over to solving this problem. So we can approach it in 2 ways. First is the DFS way, and the second one is the BFS. So firstly, I'll discuss the DFS solution. So the problem statement is that we are given a list of employee objects where each employee has an ID, that is a unique integer, an importance value, that is integer, and a list of subordinates represented by their IDs, which is a vector of integers. So our task is that given the ID of a specific employee, we need to return the total importance value of that particular employee and all of the subordinates recursively, that we're going to do using DFS. So intuition is that this problem can be visualized as a graph or tree traversal problem, where each employee that we have is a node, right? And the subordinates represents the edges. So these are the edges, right, from the current employee to their children. So these are the children, right, which are the subordinates. And we need to traverse this tree starting from the given ID. Let us say we are at ID equal to this node value of this particular node, and accumulate the total importance, that is from this and from this left subtree as well as right subtree along with this node's importance. So a DFS is a natural fit, yes. So our approach is basically we build a hash map. So an unordered map would work since we are only given a list of employee objects. We build a map from ID to the employee pointer. So ID to employee pointer, right? And this allows O of 1 access to any employee to given their ID. So this happens in constant time, right? So it helps us in reducing our space complexity. Along with that, we can perform finally the DFS that is applied. So start with the given employee ID, add the importance of this employee. For every subordinate of this particular employee, recursively calculate the total importance and add it, right? And complexity, as I said, O of n, each employee is visited once, and space complexity for hash map O of n and recursion stack is O n, right? Hash map O of 1 and recursion stack O of n. Now let us go over to the code and show you exactly how it's working out. So let me show you here. So this is our DFS code. Let me uncomment it, and this is the BFS one. So what we are doing here in this code is basically we are using recursion to calculate the total importance of a given employee, right? So get importance is our main function, which takes a vector of employee star, that is the basically definition for employee is given here, class employee. We have ID, importance, and vector of subordinates, right? So vector of employee star employees as the array, and int ID that we have to calculate the total importance for. So unordered map we take int employee star emp map. So for each employee in the employees vector, we just set the map, basically map the ID with the employee, right? And finally return the answer that we'll get from DFS, in which we're passing the ID and the unordered map, right? So we take the employee from basically the ID, particularly from the map that we stored it in, right? So we take the employee value and get the importance value for that particular employee. That is the own value for that particular employee. So let us say we have this employee. Wait a second. So for this employee, we have stored. This is the employee, right? So for this employee, the employee's importance I have stored in imp. Imp is basically an integer value which is denoting the importance. So for the basically for each sub employee ID in the subordinates, so we're traversing through the subordinates vector, that is all its children. Let us say it has 3 children, right? So for each sub employee ID, these are sub employees, right? These all are sub employees. For each sub employee, we're going to add the value of imp, like update the value of imp with DFS, a DFS call to the children of this, right? To the children of the current employee that we have. So that would be sub employee ID. We're passing sub employee ID now here, sub emp ID, and the map remains the same, employee map. So that is what we've done. That initially for DFS that we called was on the main ID, that is the senior of those particular subordinates, right? And now we are calling DFS for the sub employees that are the junior of this particular ID, so as to add the importance of the subordinates as well, since we are visiting all the subordinates in the subtree, right? And we add that into importance to get the summed up value, the total sum, right? That is the total importance of given employee, and that is how you code up the DFS part, right? So this is the DFS solution, and yeah, it has been accepted. So now let us go over to our BFS solution. So let me comment this out. So this is our BFS solution. Yeah, so let me just first talk about the approach. So think of each employee as a node in the graph and the manager subordinate relationship as edges, as we did for DFS as well. So now we need to traverse all nodes reachable from the given employee ID and accumulate their importance values. Instead of using recursion now, that is the DFS, we can now use breadth first search, in which we can start from the given employee, use a queue, right? Level order traversal is done, so a queue is used here to explore the subordinates level by level and accumulate the importance value that is added for each visited employee. So the approach is step by step. We firstly build a map, create a hash map employee ID to employee, which is employee map, the same thing that maps employee ID to the actual employee object, which allows us to quickly retrieve it in over one time, right? So over one time. Now use a queue, initialize the queue with the given employee ID. While the queue is not empty, pop an employee ID from the queue, add that employee importance to the total, and add the subordinates IDs to the queue. So a simple BFS traversal. So let me just show you the BFS part again, right? So this is the BFS code, get importance. So we maintain a map for the particular ID and that employee. So unordered map. For each employee, we store the employee ID and the employee that we have. Then we start our BFS. We set total importance integer to 0, in which we'll basically be updating for each level the importance values for the employees. So we maintain a queue, right, of int type, and push the ID into the queue. That is start from this given ID, that is the employee that we need to that we are concerned about and that we will be calculating the total importance for. So the standard BFS approach that while the queue is not empty, current ID would be queued out front, and we pop it out from the queue. Then employee, the current employee we set and we get that value from the employee map, right? So we get the current employee, and we add the total importance. So add the importance of the current employee to the total importance, and then push all the direct subordinates into the queue. So this exact step has been done here as well. As you can see, this exact same step, that is we are visiting all the subordinates and adding importance of subordinates. Instead of the recursive call here, we are just going to push it into the queue. So for each subordinate, that is for each junior of that particular employee, of the current employee, so for each of those subordinates, we push their IDs into the queue, so that for the next level traversal, when they come, their importance value is added to the total importance, and then we can further traverse the queue. right? Level by level, we are going to be traversing the tree. So that is basically the logic here. And finally, after coming out of this loop, when the queue becomes empty, we return the total importance that would store the total importance value of that is falling under the current employee. So that's it about the video. Let me submit it and show you the BFS is whether the BFS is running or not. And yeah, this has also been submitted. So that's it about the video.